right, this is your last extension problem for the sequences and series unit. This problem is in part 3 of your test review, number 4. So this type of question will show up on your test. If you choose not to do the extension, that's fine. You can give it a shot, but I'm telling you this will be part of your test. So you have a series 34 plus 31 plus 28 plus 25, and it says find n if s of n is negative 12. So show all your work. Now, first thing we should do, we know it's arithmetic because the common difference is negative 3. Always write down what you know. We know we're going down by 3, and the first term is 34. Now, we want to find n. We know the sum of all the terms is negative 12. We don't know what n is. I also don't know what a sub n is. So when I'm finding the sum of this arithmetic series here, I have to use this formula. I know a sub 1, I don't know n, I know s sub n. We know this is what we're trying to find. A sub n I need, but I also don't know. But the thing about a sub n is I can write a formula for a sub n. Okay, I can write something to fill in for a sub n, even though I don't know the number. So I use the information over here that I do know. I know the first term is 34. Remember, to write this a sub n formula, I'm using the arithmetic sequence formula. 34 minus 3 times n minus 1. And I'm going to simplify that. See how a sub n is in terms of n? Well, n's the variable I'm looking for, so that's okay. It's okay that it's in terms of n because we're going to be that. So I have 37 minus 3n. That's what a sub n is. Now that I know that information, and I know this information up here, I can at least fill in the s sub n formula. Okay, so I'm going to scroll down here a little bit. Let's lock this off. Okay, so I know s sub n is negative 12. And I'm going to set that equal to n over 2. Right, I'm just following that s sub n formula. Leave it here if we need. Times the first term, which is 34. Plus a sub n. Well, a sub n is 37 minus 3n. Now, the good thing about this formula is that the only variable now is n. That's the variable I'm looking for, so I can go ahead and solve this. I'm going to combine like terms inside the parentheses. So I'll have negative 12 equals n over 2 times 71 minus 3n. Okay, now I'm going to get rid of that denominator of 2 first. So I'm going to multiply both sides by 2. I'm going to cancel that 2 off, which will give me negative 24 equals n times 71 minus 3n. And then I'm going to distribute the n on the right-hand side. Okay, so just like the other extension problems, I'm going to put this into a form so that I can factor it or use the quadratic formula. You could move the 24 from the left over to the right. When you do that, though, you have a negative in front of the n squared, which is okay. You're just going to have to factor out a negative GCF so that you can factor. Or you can use the quadratic formula. I'm going to factor here, though. So what I'm going to do is I'm going to move both of these terms over to the left so that the 3n squared becomes positive. So I'm going to add the 3n squared, make it positive here, subtract the 71n, and then I have minus 24. That equal to 0. All right, you can move everything the other way. It's okay, your signs will just be opposites. Now, to factor this, there's no greatest common factor, so I'm going to use split the middle. And remember, like I said, you can use the quadratic formula here, you can use your calculator. This is good. So 3 times negative 24 is negative 72. And I need two numbers that multiply to negative 72 and add to negative 71, which is actually negative 72 and positive 1. So I'm going to split the middle here. The 3n squared comes down, minus 72n, forgot the 2, plus 1n, minus 24. All right, and I'm going to split the middle, or group, I'm sorry. So the GCF for that first group is going to be a 3n, and when I factor out 3n, I'm left with n minus 24. The GC after the second group is positive 1, and I'm left with n minus 24. So your factored form here is 3n plus 1 times n minus 24. Remember that once you're in this factored form, you can use something called the zero product law that says that you can set each of these factors equal to 0 to solve for n. We're going to hit that in Unit 7 after Thanksgiving. Then I just solve each of these equations for n. n on the left here becomes negative 1/3, and here becomes positive 24. The solution, I actually cannot use negative 1/3 because n is the term number, and the term number cannot be a fraction, right? Here, n could be 24. I can add up 24 terms. I can't add up negative 1/3 terms. So your answer is 24. If you need help on the extension, just ask your teacher.